Okay, for this one, let's see if we need a free body diagram. This one is a dead giveaway. It says what's the magnitude of the force. So they want me to calculate a force, so that's a dead giveaway. You have to use a free body diagram for that. Okay, so there's three things in there. There's a spiral. Now that thing is being held fixed by something. I don't know what it is, I don't care what it is, and so I'm not going to draw a free body of that, because all it would do is have an unknown that would do that. The other one is this straight slot. I'm not going to do a free body of that, because somebody is grabbing that, making it have the acceleration and velocity that is given. And I don't know who it is, I don't know where they're touching it, I don't care, so I'm going to leave that alone. The only thing that's in there is the peg. So I'm going to draw a free body diagram of the peg. So here it is, this little dot over here. That's the peg. There's gravity on here, so gravity points down towards the bottom of the page. So you've got your gravity force. The other thing is the straight slot is applying pressure. That's this guy right here. I'm going to call him the NSS for straight slot. So that's the pressure that's coming from the straight slot from this guy right here. It says that it has a friction. It's sliding, so therefore I know it's mu k times the pressure that's pushing them together. The problem says that it is slipping inward, and friction opposes the slip, and so the friction arrowhead goes to the left. The NS is perpendicular to the straight slot, so in other words it's either straight up or straight down. I don't know which. If I get a positive, I'm right. He's pushing me up. If I get a negative, I'm wrong. He's pushing him down. The friction, okay, we've talked about friction. Okay, other forces are the contact coming from the spiral, from the curved slot, and that's the NC right here. So this force is perpendicular to that tangent line right here. So I just drew it in dotted line just to get your bearings. So if it's 72.3 degrees there, then this guy right here is 90 minus 72.3, 17.7. So that's a free body diagram. Once I have that, I'm going to sum forces, and because I know R and theta, theta dot, all that stuff, I think polar would be the best thing to use, so I'm going to use polar. So the first equation here is the summation of forces in the radial direction. The radial direction always is, you draw a line from here straight out the particle, like that, and so that's the radial direction right there. The theta direction is always perpendicular, and it's in the direction of positive theta, which is counterclockwise, right? That's counterclockwise. So you go 90 degrees counterclockwise from the NR, and you get the N theta. So there's your N theta direction. Okay, so when you sum forces in the radial direction, you have the friction force, UKNS. You have a piece of the NC force, and that's the cosine. So you drop a triangle this way. But the legs are always in the directions that you want to converting into, and so the hypotenuse is along here. Okay, so that would be cosine of the angle, 17.7, equals mass, which is 1, times, and then this term right here is the acceleration in the radial direction. Okay, if you sum forces in the theta direction, the NS is backwards, so that's a negative. You have some gravity, all of the gravity actually is in the theta direction, and then you have a component of the NC force, and that equals the mass times the acceleration in the theta direction. Okay. So if you circle the unknowns, there's 1, 2, 3, 4 unknowns. Now this is 1 degree of freedom. I should have counted that. 1 degree of freedom. Because I know theta double dot, that's an acceleration term. Since I know that, I should be able to find all of the other double dots. Also, since I know a 1 dot term, I ought to be able to find all 1 dot terms. That means that this R double dot should be findable, and this R dot should be findable. Okay, so how do you do it? Well, you've done a lot of homework problems with that. So here's the equation for the R in terms of theta. So to take a derivative, you just take, just don't forget the chain rule. So hopefully this derivative makes sense. And when you plug numbers into that, you get negative 0.81 for the r dot. By the way, if you plug in the values for theta, remember that this has to be in radians. You're going to get your r is 0.637. Okay, so now to find the r double dot, take the derivative of this. I treated it as a product, so it's this term times the second one plus, right, so there's two terms that are multiplied together. And so here's the second derivative of that. Not too hard, I don't think. And then you plug numbers in. So you just plug in theta dot is 4, so that's 4 times 16 over pi cubed. 2, theta double dot is 3, so 2 times 3 divided by pi squared, and so you end up with your r double dot. So now you know all of these numbers. All I'm going to do is I'm going to take the r dot, r double dot, I'm going to plug them into the force equations and just simplify. So mu k is 0.1, so there's my mu k in s. I'm just bringing this one down. And then just, punch it out, and just plug numbers in, plug and chug. So this is the first equation. The second equation comes down here, and again, you just plug the numbers in, do some calculating and whatnot. Okay, so then I just, all I did was I simplified a little bit. I took the top equation and multiplied everything by 10. So multiply this guy by 10, you get ns. Multiply this by 10, you get 9.52. Multiply this number times 10, you get a negative 87.36. And then I just simplified the second one, right? If you just punch in numbers from your calculator, you get this. And then if you notice, these guys are, ones plus, ones minus. I'm just going to add these two black equations together. And so the ns disappears. And then 9.52 plus 0.304 is 9824. And then these guys added together gives you a negative 101. So it's very easy to calculate NC. Once you have NC, you just come over here and grab the NS. NS is equal to minus 8736 minus this stuff. You know what that is. So you can calculate the NS. Once you have the NS, you just pop it in right up here. I didn't ask for it, but you can tell that the NS is a positive number. Right? So that's a positive number, which means that what I thought it was doing is correct. So I thought it was holding it up, and I'm right. So it goes up. That's it for that problem.